Section 9.4, Graphing Quadratic Functions. So now we're going to look at the graph of a quadratic. The graph of a quadratic is a parabola, and the parabola has a vertex and an axis of symmetry. The vertex is either the highest point or the lowest point on the graph. It depends if the parabola opens up or down. The axis of symmetry is a line that divides the parabola into two symmetrical parts. So you have a vertex, either the lowest point or the highest point, and you have a line of symmetry. So parabolas can either open up or they can open down. So looking at these parabolas, this point right here would be the lowest point, so that would be the vertex. This is the highest point, that would be the vertex. It's where the parabola starts changing from increasing to decreasing or decreasing to increasing. Your line of symmetry is a line that goes through your vertex, where every point on one side of the parabola can be mirrored imaged over to the other side. It does need to be symmetric. We have two ways to write quadratic equations. We've seen this form a lot recently, f of x equaling ax squared plus bx plus c. But a new form that I need you to know is f of x equaling a parentheses x minus h quantity squared plus k. They're both quadratic equations. One is written in what we say old standard and the other one is in the new standard. So if a, and we can see a in front of the x squared, or we can see a in front of the parentheses. If a is greater than 0, meaning positive, the graph will open upward. So the vertex will be the lowest point on the graph. If a is less than 0, then the graph opens downward. So therefore, the vertex would be the highest point on the graph. What are the things we need to graph a quadratic function? Well, the first thing we'd like to find is the y-intercept. And how do we find the y-intercept? We let x be 0. The other thing we would like to find, if they exist, are the x-intercepts. And how do we find the x-intercepts? By letting y be 0. Now, why do I say if they exist? Because if the parabola opens above the x-axis or opens downward and below the x-axis, you're not going to have any real x-intercepts. You'll always have a y-intercept if it opens up or down, but you won't always have x-intercepts. So be careful on that. You also want to find the vertex, that point where it's either the lowest point on the graph or the highest point on the graph. To do so, if you're in the form of f of x equaling ax squared plus bx plus c, we have a formula. And the formula is opposite of b over 2a, then whatever that number is, you plug it back in to find the y part of the vertex. Now, if you're in the form of f of x equaling a parentheses x minus h quantity squared plus k, the vertex pops out. It's the opposite of 1 in the parentheses, so change your sign for the h, and k stays as is. So we have two different forms that we're going to have to deal with. Either ax squared plus bx plus c, we're going to need to have a formula to find the vertex, or if you're in the new form of f of x equaling a parentheses x minus h quantity squared plus k, the vertex pops out for you. So let's do some problems. For the following problems, we're going to state whether the graph opens upward or downward. We're going to find the coordinates of the vertex, write the equation of the axis of symmetry, graph, and then state the domain and range. So for number 1, we have y equaling x squared minus 2x minus 3. Well, we need to state whether the graph opens up or down, and we do so by looking at a. The number in front of x squared is a 1, and that means it's greater than 0, so it's going to open up. So just make a note that your graph should look something like that. Now we'll need to find the vertex. And how do we find the vertex? When it's in this form, we have to use the formula of opposite of b over 2a, and then whatever that number is, we plug it back in to find the y part of the vertex. So opposite of b, so opposite of negative 2 to be positive 2, all over 2 times a, and a is 1. So 2 divided by 2 is 1. So that's the first part, the x part of the vertex. Now we need to find the y part. And how do we do so? By plugging in x being 1. So y is going to equal 1 squared minus 2 times 1 minus 3. 1 squared is 1. Minus 2 minus 3 is going to turn out to be a negative 4. And that's the y part of the vertex. So my vertex is 1, negative 4. So let's go ahead and plot that. 1, negative 4. Now, let's go ahead and find and write the equation of the axis of symmetry. Well, your axis of symmetry is that line that goes through the vertex. So your axis of symmetry is always going to be of the form x equals, because it's a vertical line, and it went through 1, so my axis of symmetry is x equaling 1. Now we still need a graph. Well, to graph a quadratic, I need about 5 points. So I'm going to go ahead and make a table. And with my table, I'm just going to plug in some values that are close to my vertex. Since the x part of my vertex is 1, I'm going to see what happens at 0 and at negative 1. So I'll plug in a 0 into my original equation. So y is going to equal 0 squared minus 2 times 0 minus 3. So I get 0, negative 3. That's actually the y-intercept, because how do you find the y-intercept? You let x be 0. Now, because we have a line of symmetry, we can mirror the image that point over to the other side. So we're going to be 1 unit away on the left, so it'll be 1 unit away on the right. Now let's try negative 1 into my equation. So y is going to equal negative 1 squared minus 2 times negative 1 minus 3. Well, negative 1 squared is 1. Negative 2 times negative 1 is a positive 2 minus 3. So 1 plus 2 is 3, and 3 minus 3 is 0. So negative 1, 0 is a point on the graph. And as you can see, that's actually an x-intercept. I'm 2 units away, so I'll go 2 units to the other side, making it be symmetric. And so my parabola is going to look something like that. Graphing 5 points is always the best thing to do, so you can know how wide or how skinny your graph is. Lastly, part E says state the domain and range. Your domain says what x values have you used, and the range says what y values have you used. Now, when you talk about domain and range, know that with domain you go from left to right, and with range you go from bottom to top. So left to right, we have used every single x value. So negative infinity to infinity is my domain. But if you look at your range going from bottom to top, you don't use any y value till you get to the vertex. And the y part of the vertex was negative 4. So your range goes from negative 4 to infinity. Number 2, y equals negative x squared minus 4x plus 5. First thing they asked us to do is to state whether the graph opens up or down. So we need to look at a. A is a number in front of x squared, so that's negative 1, which means it's less than 0. So this graph is going to open down. Part B. Part B says let's find the vertex. Well, it's in the form where we have to use a formula of opposite of b over 2a, and then plug that number back in to find the y part of the vertex. So opposite of negative 4 would be a positive 4 all over 2 times a, and a is negative 1. So I end up with a negative 2 as the x part of my vertex. Now I need to plug that back in to find the y part. So y is going to equal negative 2 squared minus 4 times negative 2 plus 5. According to order of operations, I should do powers first. So negative 2 squared is 4, but that turns out to be a negative 4 because of the negative on the outside. Negative 4 times negative 2 is positive 8, and then I have plus 5. So negative 4 plus 8 plus 5 is going to give me a 9 for the y part. So my vertex is negative 2, 9. So let's go ahead and plot negative 2, 9. It'll be right about here. And then I'll draw my line of symmetry. Again, my line of symmetry goes through my vertex, so every point's going to be symmetric over my line of symmetry. So part C, my line of symmetry is x equaling the x part of my vertex, which is negative 2. So part D says to graph. Well, let's go ahead and try and find the x-intercept and the y-intercept if they exist. So let's find the y-intercept. To find the y-intercept, I let x be 0. When I let x be 0, I end up with just 5 because I put a 0 in for x. My 0 times anything is 0, so those go away. I'm just left with 5. So 0, 5. Because I know that's my y-intercept and I'm 2 units away, I can mirror image it over to the other side. So 2 units over to the other side, and I have a third point. If you want to find your x-intercept, you're going to let y be 0. Or if you want to just do a table, choose a point that's close to your vertex that you haven't already found. So I could plug in a -1 and see what happens for the y value. So I'm just going to plug in a -1. So y is going to equal -1 squared minus 4 times -1 plus 5. -1 squared is 1, but the negative on the outside makes it a -1 plus 4 plus 5. So that's going to give me an 8. So another point on my parabola is -1, 8. And I'm 1 unit away, so I'll go 1 unit over to the other side, and then I'll just draw my parabola. It also asks for the domain and range. So for part E, I need to find the domain and the range. Again, the domain says what x values did you use, and you used all x values from -infinity to +infinity. So the range goes from bottom to top, and we are starting at -infinity because we're pointing down, so -infinity, and we go all the way to the top of my vertex y value, and the vertex y value is 9, so I went from -infinity to 9. We do include the 9, so the 9 is going to have a bracket. We never include infinity, so always use parentheses. Number 3, y equals -x squared plus 1. First things first is to decide if it opens up or down. So we find A is -1, so that's less than 0, so we know this is going to open down. So just make a little note that you know your parabola opens down. Part B says to find the vertex. Well, the vertex is the opposite of B over 2A. There is no B, so the opposite of B would be 0 over 2 times -1 is still 0. So when I plug in a 0 back into the equation, I get 1. So my vertex is at 0, 1. So if B is not there, you know that B has to be 0, and so therefore your vertex part of the x-coordinate is 0. Part C, we needed to find more of our line of symmetry. Our line of symmetry goes through the vertex. So our line of symmetry is going to be this vertical line. It's going to be x equals, and the x part of my vertex was 0, so my line of symmetry is x equaling 0. The next step is just to graph. Well, you can decide how you want to graph. I'll just make a table, and I'll plug in values that are close to my vertex of the x part 0. So I'm going to plug a 1 and a 2. So when I plug in a 1, I get y equaling negative on the outside, and then I have 1 squared plus 1. 1 squared is 1 times a negative is a -1, and -1 plus 1 is 0. So 1, 0 is one of the points. I'll mirror image it over to the other side. When I plug in a 2, I get negative 2 quantity squared plus 1. 2 squared is 4, so I get a -4 plus 1, which gives me a -3. So 2, -3 is another point. I'm 2 units away from my line of symmetry, so I'll go 2 units on the other side, draw my parabola, and don't forget to put arrows to show that it continues going down. So what's my domain? What x values did I use? I used all x values, so -infinity to infinity. What is my range? My range says, well, I am pointing down, so I am going from -infinity, and I stop right at that top of my vertex, y part of my vertex. So -infinity to 1, and 1's going to have a bracket. Number 4, f of x equals -1/3 parentheses x plus 2 quantity squared plus 4. So this is in the new form. Well, let's go ahead and start with the directions. We need to find A, and A is -1/3, so it is less than 0. So again, this is going to open down. Alright, so we'll just make a note that we know our parabola opens down. Part B is to find the vertex. Well, when we're in this form, the vertex pops out, so we don't have much work to do. The vertex is the opposite of 1 on the inside, so it's going to be a -2, and the outer one stays the same, so it's going to be a +4. So my vertex is -2, 4. So let's go ahead and plot a vertex, -2, 4. Then we're going to do our line of symmetry. Our line of symmetry is just that vertical line that goes through your vertex. So my line of symmetry will go through my vertex. And it's going to be an x equals, and it's going to equal -2. So x equals -2. Then we need to graph it. So I'm just going to choose some points that are close to my vertex of the x value of -2. So I'm going to try -1 and 0. So when I plug in a -1, watch what happens. So y is going to equal -1/3. I get a -1 plus 2 quantity squared plus 4. That doesn't work out very well because that doesn't give me a nice integer value for me to plot. So I'm actually not going to plot negative 1. Let's try 0. I have y equaling negative 1/3, and I have 0 plus 2 quantity squared plus 4. That one doesn't work out very well either, because 0 plus 2 is 2, and 2 squared is 4, not divisible by 3. So I really don't like either of those. So when you get into fractional ones, you kind of have to be a little bit picky on what you want to plug in for your x values. What if I plug in a 1? I get y equaling negative 1/3, and I have 1 plus 2 quantity squared plus 4. Well, that's one I can do because I'm going to have negative 1/3. 1 plus 2 is 3. 3 squared is 9. And I know that 9 times negative 1/3 is negative 3. And negative 3 plus 4 is 1. So one of the values I want to plot is 1, 1. So just be picky on the values you want to plug in and make sure that when you do plug them in, you get a nice value. So what about 4? If I jump to 4, I get y equaling negative 1/3, and I have 4 plus 2, sorry about that, 4 plus 2 quantity squared plus 4. Well, 4 plus 2 is 6, and 6 squared is 36, and then I still have plus 4. Well, negative 1/3 times 36 is negative 12, and negative 12 plus 4 is negative 8. So another point that I could plot that's nice is 4, and then negative 8. I'm 1, 2, 3, 4, 5, 6 units, so I need to go 1, 2, 3, 4, 5, 6 units to the other side. I was 1, 2, 3 units on that one, so 1, 2, 3 units to the other side. So now I can see that my graph of my parabola is pretty wide. So now I'll need to find my domain and range. The domain says what x values did you use, and I used them all, so negative infinity to infinity. The range says what y values did you use. It was pointing down, so I went from negative infinity, but I stopped at my vertex, and my vertex y value was 4, so negative infinity to 4, and 4 is going to have a bracket. Find the vertex and 2 convenient points to graph the following. Y equaling x squared minus 2x plus 3. So here it just wants a vertex and 2 convenient points. So number 5, y equaling x squared minus 2x plus 3, is in the form where we have to do the work to find the vertex. So how do we find the vertex in this form? We do opposite of b over 2a, and then we plug that number back in. So opposite of negative 2 would be positive 2, all over 2 times a, and a is 1. So the x part of my vertex is 1. When I plug that back in, I end up with 1 squared minus 2 times 1 plus 3. 1 squared is 1, minus 2 plus 3 is 2. So my vertex is 1, 2. So when I plot 1, 2, I can go ahead and do my line of symmetry, because if I want to find one point and mirror image it over, then I already have a second convenient point. So what value would I want to choose? Well, I could find my y-intercept. And how do we find the y-intercept? We let x be 0. So if I let x be 0 and plug in a 0 for x, I get 3. So my y-intercept is 0, 3. I'm 1 unit away on the left-hand side, so I go 1 unit away on the right-hand side. And now I know that my parabola opens up. So that's if they don't want 5 points. If they just want the vertex and 2 convenient points, you can go ahead and graph it pretty quickly. So I'm going to give you the answer to number 6, and you can try that one on your own. If you try number 6, you should get a vertex of 2, 2. So we'll plot 2, 2. We have a line of symmetry going through my vertex. And one convenient point would be the y-intercept, and the y-intercept is negative 2. So I'll put a dot at negative 2. I'm 2 units away, so I go 2 units to the other side. I do know it opens down. So there's the graph of my parabola. Application problems. The last 2 problems in this section are word problems, but they're really wanting you to find either part of the vertex, an x-intercept, or a y-intercept. So you just have to figure out what piece they're wanting you to find. Number 1. A ball is kicked with initial velocity of 36 feet per second. The equation h equaling negative 16t squared plus 36t describes the height h of the ball in feet t seconds after being kicked. So what is this going to look like? Well, if I look at the coordinate plane and I see that my h equaling negative 16t squared plus 36t doesn't have a plus anything, so it's a plus 0. So I know it's going to start on the ground. And it gets kicked, so it comes up, and then it goes back down and it hits the ground. Now how did I know it opened down? Because by negative 16, that's A, so I know it's going to open down. So what is the x-axis representing? Well, that's your time, so time goes horizontally. And then what is your y-axis representing? Well, that's your height. So this is how high it's going. So part A. After how many seconds does the ball reach its maximum height? Underline maximum. 99% of the time it's going to want the vertex. So after how many seconds does the ball reach its maximum height? So we're looking for this piece right here, and that's the x part of the vertex. So for part A, I do want to find the vertex, but just the x part. And how do we do that? Opposite of B over 2A. It said it wanted to know after how many seconds, so I just want the t. So opposite of B, so opposite of 36, so negative 36, all over 2 times A, and A is negative 16. So just the t part of the vertex is 1.125 when I plug that into my calculator. So it takes 1.125 seconds to reach the maximum height. Okay? Part B. What is the maximum height? Well, that's when you plug the t back in. That's going to give you the maximum height. So part B is when you have h equaling negative 16 parentheses 1.125 quantity squared plus 36 times 1.125, because this is the maximum height, and now we're looking for the y part of the vertex. When you do that into your calculator, you're going to get 20.25 feet. So the maximum height is 20.25 feet. Part C. How long is the ball in the air? Well, it starts on the ground, it's in the air, it's in the air, it's in the air, and then it's not in the air again. So how long is the ball in the air? Well, halfway was when we were at 1.125 seconds. So it's going to take another 1.125 seconds to hit the ground. So all I got to do is take 1.125 and multiply it by 2, and I get 2.25 seconds that the ball was in the air. Number 2. The function c of n equaling n squared minus 100n plus 5,000 describes a company's cost, c, of producing n units of its product. Find the number of units a company should produce to minimize. Anytime you see maximize or minimize, 99% of the time, they're wanting you to find the vertex. So look at this problem. We do have a plus 5,000. So we know that our y-intercept is 5,000. It opens up because the number in front of n squared was 1. So I know my graph is going to do something like that. So what are we trying to find? We want to find the minimum number of units that should be produced to minimize cost. Find the number of units the company should produce to minimize cost. So this is the vertex. That is the minimum. So do they want the x part of the vertex, or do they want the y part of the vertex? That's what you have to decide. Well, we want to find the number of units. The number of units, n is the number of units. So if I'm looking for my vertex, the only piece that I want is the opposite of b over 2a. If I plug that back in, that would give me the minimized cost. So opposite of b, so opposite of negative 100 is 100, all over 2 times a, and a is 1. When I divide that out, I get 50. So they need to produce 50 units to minimize the cost. So just try and figure out, do they want the x part of the vertex or the y part of the vertex? And that should help you on the word problems when they say minimize or maximize.